Hello and welcome to the Bearded Mathman's YouTube channel. Hey, do you remember not too long ago you learned about algebraic fractions? Those were the ugliest things you'd ever seen in your entire life. Well, what's next? What follows that idea are rational equations. That is, equations where we have fractions and our variable is in the denominator. Before we get into it though, as you're watching the video, I'd like you to think of two things. If you think this video would be useful for somebody else or helpful, if you give it a thumbs up, it'll make it easier for other people to find it. Now, if you find this to be useful for yourself and you want to be notified when some new videos are released, please click subscribe. I mean, what do you got to lose? It's free, right? Now, as we're going through this video, my goal is that you really understand what you're doing. So you know what you're doing, you know why you're doing it, you can do it quickly. That's proficiency, and you're going to remember. All right, so the reason that this is so important is this topic, these rational equations are kind of a gateway. If you can master this topic, math's not really going to be that big of an issue. All of the math that follows is tricky because of this kind of algebra, but we're going to be very careful. We're going to take our time. We're going to make sure that you patiently understand what it is you're doing, and then all of it's going to be accessible, right? So let's get into it. To start, let's talk about some things we learned about algebraic fractions or rational expressions that you may have forgotten but are going to be really important moving forward. The first is that the value x is considered prime because we can't factor it besides 1 times x, right? Now, next thing, lowest common multiples are king. They are super, super important. We're going to use them in lots of different ways. So here, with a denominator of x and another denominator of 5, the lowest common multiple is 5x. One last piece of information, and we're going to talk about this in the next slide, but in order to reduce, you have to have a greatest common factor between all of the terms. All right, so let's get to an example. So we've got our expression here, and let's go ahead and make that expression into an equation. Now, there are two ways we can use the lowest common multiple to help us solve for x. The first way is probably most familiar, and that's using a common denominator. So what we're going to do, as we said, the lowest common multiple of x and 5 is 5x. So we have to multiply this first number by 5 over 5, and this second number over here by x over x. So 5 times 8 is 40, negative 3 times x is negative 3x. Now, it would be really nice if these x's would reduce, but they don't. And the reason they don't is this entire thing here, this entire expression has one term, two terms in the top, one term in the denominator. They don't all share a common factor. Sure, 5 and 40 share a factor of 5, and 3x and 5x, they share a factor of x, but not all three have a common factor, so we can't reduce it. But what we're going to do is we're going to multiply both sides by this, you see, by that 5x right there. And what's going to happen is the 5x reduces with 5x, and over here the x reduces with x. That doesn't always happen, but what we're going to see right now at this level, that's typically what's going to be happening, because this lesson's intended for people that don't really know how to handle things that have exponents more than 1. So like you want to be able to do x squared minus 3x equals 11, for example. However, if you're struggling with algebraic fractions and you're at that level, this can still be very helpful for you. So now, after we reduce, what we got is we have a simple one variable equation. No problems from here. You just use your inverse operations. And if you're having trouble with basic inverse operations like this, I will put a link in the show notes in the description down below that'll get you the help with that you need. Now, let's talk about the other way that we can use the lowest common multiple. What we can do is we can take the lowest common multiple and we can multiply it by every single term on both sides of the equal sign. So we have two terms on the left, one term on the right. In this example, we're going to multiply everything by 5x. Now, we aren't getting a common denominator right here. What we're doing is we're using the fact that the lowest common multiple, this, will reduce with x, and it will reduce with 5. So we're multiplying everything by 5x over 1. We're not doing like we did earlier, multiplying by 5 over 5 or x over x. We're multiplying by 5x over 1. What's going to happen when we multiply these two together, the x's are going to reduce. We're going to have 40. When we multiply 5x times 3 over 5, the 5's are going to reduce, and we're going to be left with a negative 3x. And over here, the x's are going to reduce, and we're going to have 20. Do you see? Now, we have the same thing we had here, so the steps are going to be the same, no problems. Now, in this situation, this way was easier, right? Multiplying everything by the lowest common multiple has fewer steps. But you need both, because sometimes this way over here works really, really well, and sometimes this way works easier. You need a full toolbox so you can handle anything that comes your way, right? So here's what we're going to do. I would like you to try both methods on this example. It's almost the same exact thing. So go ahead and pause the video, give it a shot. When you're done, unpause it. All right, did you try it? Don't be lazy. I mean, you can pause it and you can get up and go get something to write with. Really, give it a shot. All right, so here's the deal. If you found a common denominator, you had to multiply by 2 over 2 and by x over x, and you would get 6 minus 5x over 2x. And then when you multiply by both sides by 2x, the x's reduce, and from there you should be all right. This one, when you multiplied by the lowest common multiple and you reduced, you skipped all of this right here, and you just ended up, right here. So in this example, again, multiplying everything by the LCM was a little easier, but that's not always the case. All right, so if you did not get this correct right here, why don't you go ahead and try this problem I'm going to put right here on the screen for you. Go ahead and give that a shot. See how you do. All right, once you're done, we're going to move on. We're going to see the next level of complexity. Now, it's not entirely different. It's just a little bit trickier. Now here, since we have a denominator that has the x with it, that's a binomial, it might be a little tricky to multiply everything by the lowest common multiple. So it might be smarter to get a common denominator. So we're going to do that by multiplying this by 4 over 4 and this by x minus 2 over x minus 2. When you see it printed like this, and this is how you'd see it often in a textbook or in notes, it can be a little overwhelming. So if you just highlight it or you change the color, you can see maybe a little better what's happening. So anyway, let's go ahead and multiply. This is going to be 12, that's x minus 2, and we're going to multiply these denominators together here to give us 4x minus 8, right? Now, here, we're going to combine like terms. 12 minus 2 is 10, and we're going to multiply both sides by 4x minus 8. This is going to give us 20x minus 40. Over here, these reduce, and from here, it's just an application of inverse operations. One thing that you might want to remember is that we have two x's. They're separated by an equal sign. So we have to do the inverse of one of them. It's almost always better to move the quote-unquote smaller one. So the term with the smaller coefficient, do the opposite of that. So we're going to subtract x. And since we're going to move the x's to the right side of the equal sign, we're going to get rid of the 40 by adding it. And then all you got to do is do your inverse operations, and boom, you're done. Now, if you have trouble with inverse operations, I'm going to put a link in the description below to give you some help, all right? Now, this same problem right here gets infinitely trickier if this was a minus sign. Instead of a plus, if this was a minus, like this, oh, it's trouble. With practice, most students, after they get proficient, most students will get this right 100 times out of 100 times. Just takes a little bit of practice. But this one over here, oh man, same level of proficiency, but I believe that it's going to be 25 out of 100 times that people are going to get this one right because of that negative sign. Oh, it is so tricky. It's so nasty. So let's see why. Let's see if I could equip you so that you do not fall for the trap. Oh, and this is such a creepy picture. I absolutely love it. Anyway, just like before, we're going to get a common denominator, right? So this is going to be 12, but over here is where we're going to get into trouble. See, these are fractions and they're subtracting. The denominators do not subtract. When you're adding and subtracting, the denominators do not change, but the numerators do. So this is 3 minus 1. So this is minus 1 times x minus 2. So this is going to be minus 1 times x and minus 1 times negative 2. It's a little easier to make sure you don't mess up if you write it with parentheses, but we don't really write it that way. That's not how we do it, but that's what's going on. What people get wrong all the time is they write minus x minus 2, and that's wrong because we're distributing a negative 1. So anyway, let's go ahead and move forward from there. Do you see? Again, most people would have minus x minus 2, and that gives them 10 in the numerator instead of 14. And that's a bit of a problem. But from here, we have we're at this level over here, and it's pretty much the same. We're going to multiply both sides by 4x minus 8. We're going to combine like terms in the numerator. So when we add 40 to 14, we get 54. And when we divide by 21, the reason it's 21 is because this negative 1 is definitely smaller than 20. So we're going to add 1x to both sides. This is reducible. You got to make sure you reduce. It's divisible by 3. 5 plus 4 is 9. Since 3 goes into 9, 3 is going to go into 54. And it goes in 18 times. And then 3 goes into 21 7 times, of course. So you have to be careful when you're distributing those negatives. Oh, be super careful. All right, let's try one. Your turn. You try this one right here. Just like before, go ahead and pause the video and give it a shot. When you're done, unpause it, and I'll walk you through it. All right, so what we're going to do right here is we're going to go ahead and get a common denominator. So we're going to multiply this side by 3 over 3, and this side by 2x minus 1. Now, it's minus 4 times 2x, which is negative 8x, and it's minus 4 times minus 1, which is 4. So combining these two, you get negative 5. I'm going to multiply both sides by 6x minus 3. Now this is smaller, so we're going to add it. It's going to give us 11x. And since we're going to move the x to the right, we're going to go ahead and add this. It gives us 7. Boom, done. All right, so let's pull it all together right here, shall we? So the LCM has 2 roles here that you can use. You can find the lowest common multiple, and you get a common denominator and solve that way. Or with the lowest common multiple, you can distribute to all terms on both sides of the equal sign, and those denominators will all reduce. Because all of the denominators go into this number, they are all going to reduce, and then you end up with something that's a lot simpler, right? However, you need to have both tools in your toolbox, because sometimes this way right here is super easy and this way is difficult, but sometimes the common denominator is much simpler than this way. And so if you're working and you just take a guess and you try one method and you get stuck, you can go back and try the other. Probably it's going to be easier. Now, you also have to be careful of those quote-unquote hidden negatives, like this one right here. That's distributing the negative, and you have to be really, really careful of that. If you see a rational equation and one fraction is subtracting from the other, so you got a fraction here that's subtracting from this one, you need to slow down and be very, very careful. Make sure you distribute that negative correctly. All right, last thing. The big idea, what we're really trying to do is we're manipulating these fractions to get to a place where we can just use inverse operations, and from there we should be golden. All right, now last thing. On my website, thebeardedmathman.com, I will put a link where you can access some notes, some practice materials, a lesson, all this kind of stuff. If you go to my website and you click on courses, and you can go to Algebra 1, the entire Algebra 1, an entire year's worth of Algebra 1 curriculum and content is right there, all free to use. Now, as of right now, I only have 2 sections that I'm working on, but as I work through in the next couple of months, it'll all be done, and it's all going to be fully fleshed out like this right here. Every single unit and the number unit is right here, and it's all free to use. So there are notes, practice problems, lessons, videos, all of it. Right now we're in the foundations unit, and that's where we're learning how algebra works, what algebra really is. Not algebra the class, but algebra the branch of math. And we're learning about inverse operations. We're learning how to solve stuff, right? And so if you go to that page, if you're having trouble with some of the fundamentals, you got notes, there are lessons, there are assignments. It's all right there, free to use, right? We're right now we are on the part at the very bottom, the rational equations, this part right here. And so if you go to this link right here, you're going to find notes that will accompany this video. You can read through them, you can try the examples, you can work through it, and then there's some practice problems right there to use. So anyway, that's it. So I'd like to thank you for your time. I hope you found this to be helpful and useful. If you have, give it a thumbs up and subscribe. Until next time, hope you have a great day.